Hello students, today we are going to start a new chapter that is called friction. So we are starting the chapter number 7, friction. Friction is the force which acts between two surfaces when there is relative motion between the two surfaces, and the force which opposes the motion between the two surfaces is called friction force. Suppose there are two surfaces. If these two surfaces are moving with respect to each other, then there will be a force that is acting between the two surfaces which opposes the motion is called friction force. Friction is a self-adjusting force. Now we will understand how the friction comes into the play and how it is a self-adjusting force. So to explain this, I am using some diagram. You focus upon this diagram. Suppose this is a surface and this is an object. Now there are two forces acting on the object. The first force is the weight of the object in downward direction, mg, and it's a normal reaction in upward direction, p. Clear? Then this is weight of the object, this is the normal reaction. The system is in equilibrium, the body is not moving, then this is in equilibrium. When external force as F is applied on the object like this, then the body will move in this direction. And what is friction? When there is motion between the two objects, then the force between the surfaces which opposes the motion is called friction force. When we apply force in this direction, then there will be a force in our opposite direction. That force produces in opposite direction is called friction force. That will stop the object, or it will stop the motion of the object, or it will oppose the motion, and that is called friction force. Now there are three forces acting. This is normal reaction, this is mg, and this is external force applied by an external agent, applied by the person. Suppose I am applying force in this direction. Is it clear? Then from where that friction force will come? Because here we can see only there are three forces. P, this is normal reaction, external force applied, and the weight of the object. Then from where this friction force will come? Actually what happened when we apply force in the object, then this normal reaction will tilt slightly. When we apply force in this direction, then this normal reaction will tilt slightly. Then suppose the normal reaction is now tilting like this. The normal reaction will tilt like this. Now this is P, that normal reaction. It is tilted by at an angle theta. Now there are two components of normal reaction P. This component is P cos theta, and this component is P sin theta. Clear? This P will resolve into two components, P cos theta and P sin theta. The P cos theta component will counterbalance the weight of the object mg. It is equal to weight of the object. And this P sin theta will against the friction force. And since friction force or friction is a self-adjusting force, how it is self-adjusting? If we are applying small force, then the theta will be very small. When theta will be very small, P sin theta will be very small. It will be equal. It is tilted such that P sin theta becomes equal to the external force. Listen again. It is tilted such that P sin theta becomes equal to the external force, so that these two forces will cancel out and there will be no motion. Means this P sin theta will stop the motion of the object. This P sin theta will be the friction force. Therefore this is the friction force. Is it clear? Okay. We always use for normal reaction the letter R. Therefore I am taking this R then this is r cos theta, this is r sin theta. R sin theta is the friction force and F is the external applied force. Now suppose I am increasing this force F. I am increasing this force F. Suppose see this object. Can you see this object? This object can you see? Okay. Suppose I am applying force in this direction, but this object is not moving. Why? This r sin theta, the normal reaction will tilt like this, and the component r sin theta will stop the motion, and that time r sin theta is equal to F. Now I am increasing the force. When I will increase this force, theta will increase. When theta will increase, sin theta will increase, r sin theta will increase. But again, it is only equal to the force applied, and the net force will become 0 and there is no motion. Now I am again increasing my force, increasing my force, increasing my force. Then the theta will increase, but it can maximum increase up to 90 degree. Suppose I am increasing maximum force, then the r will become like this. Then theta will become 90, sin 90 is 1. Now r in this direction, the maximum force is r, and r cos theta will become 0. This r cos theta will become 0 because cos 90 is 0. R sin theta will become to F. Now if we apply it, if we increase this force further, increase this force, then theta cannot be increased further. Then force F will become greater than the r sin theta, means r. When F is become greater than r, then the body will move. When the body is moving, then still there is a friction force, and that friction is called kinetic friction. When it is not moving, static friction. When it is moving, kinetic friction. And that maximum friction force at which the body is just about to slide. That maximum force when the body just about to slide is if we increase a little bit force, then the body will move. That friction force is called limiting friction. Then friction is of three types: static friction, kinetic friction and limiting friction. What is static friction? When the body is not moving, that friction is called static friction. When the body is just about to move, that is called limiting friction. When the body is moving, then in that situation the friction force is called kinetic friction. Okay, now you can see as we increase F, then theta will increase. Theta will increase accordingly, so that r sin theta will be equal to external force. Then in this condition we can say that this normal reaction or this friction force r sin theta, it is a self-adjusting force. It is adjusting according to the external force. That's why we are calling it self-adjusting force. Now this, what is limiting friction? When the body is just about to slide, the friction force is called limiting friction. When the body is not moving and we have applied force, that friction is called static friction. And when the body is moving, then the friction force is called kinetic friction. Now you can see that with I am showing the variation with a graph. This is the friction force. This is the friction force small f, and this is applied force. As we increase capital F applied force, friction force will increase. It will become maximum, and then slightly it will decrease and then become saturated. And this is called kinetic friction, this is called static friction, and this one is called limiting friction. Is it clear? Limiting friction, static friction and kinetic friction. Now from the diagram you can see that this is r, this one is theta, this is r cos theta, and this is r sin theta. This is external applied force, and this is weight of the body mg. Now you can see from here that since the body is not moving, suppose the body is not moving, then r cos theta is equals to mg, then r cos theta is equals to mg, and r sin theta is equals to external force, and this is also friction force. The force which opposes the motion is called friction force. This force r sin theta is opposing the motion. That's why this is called friction force. Then r sin theta is the friction force. Now friction Fs, Fk. Fs is static friction, Fk is kinetic friction, and third one is the limiting friction. Now this is, suppose we are dividing, then r sin theta upon r cos theta. R sin theta upon r cos theta is equals to F by mg. Then r cancel. Tan theta is equals to F by mg. Tan theta is equals to F by mg. And mg is equal to normal reaction capital R. Then F by capital R. This is F is equals to, okay, let it is tan theta is equals to F by mg. Now I will explain you laws of friction. Laws of friction. What is the first law? The friction force between the two surfaces is depending on the nature of the surfaces, whether they are rough or they are smooth. If for the rough surface the friction force is larger than the friction force for the smooth surface. If the surface will become smooth, friction will reduce. Okay, then what is the first law? The friction force depends on the nature of the surfaces in contact. The second one, the friction force is always tangential to the surfaces. Suppose one surface is this, second surface is this, then the friction force will be tangential to the surface. This is second law. And the third one, the friction force is directly proportional to the normal reaction. The friction force is directly proportional to the normal reaction. Clear? Then friction force is equals to, there must be a constant. That constant is mu r. F is equals to mu r. Mu is called friction coefficient. Mu is called friction coefficient. Then Fs is equals to mu sr for static friction. Fk is equals to mu kr for kinetic friction. And we also know that tan theta is equals to F by mg, because we have derived tan theta is equals to F by mg. This is F by r, and then tan theta is equals to F by r, and from here mu is equals to, from here, since F is equal to mu r, mu is equals to F by r, then from these two equations, tan theta is equals to mu, then tan theta is equals to mu, tan theta is equals to mu, F is equals to mu. Here I am again explaining you, listen very carefully. First of all, what is friction force? Friction force is the force between the two surfaces that opposes the motion of the two objects. Clear? Friction force is a self-adjusting force, because from where the friction force will come, when we will apply force in this direction, this normal reaction will tilt so that it can be resolved into two components. This component is r sin theta, this component is r cos theta. The component r sin theta is the friction force which opposes the motion. Here, and laws of friction. Okay, there are three types of friction. When the body is not moving and we are applying force, that friction is called static friction. When the body is just about to slide, that is called limiting friction. And when the body is moving, that is called kinetic friction. And see this diagram and angle of repose. This is called angle of repose. What is angle of repose? Suppose this is the object. Now we are making the inclination angle theta. The object is not moving or it is not sliding. Then this is called, this angle is the angle, any angle. Now if we are increasing, when the angle becomes equal to the some angle, then it is moving. Okay, I am explaining you. Yes. Yes, see the angle of repose. Angle of repose. What is angle of repose? Suppose I am increasing this angle of inclination, the body is not moving. Now I am again increasing, then there will be angle when the body is now moved. It is moving. The angle of inclination, that angle of inclination, for which the body is just begins to slide is called angle of repose. What is the angle of repose? That angle of inclination for which the body just begins to slide is called angle of repose. Then if this is angle of repose, then this is also called theta c, critical angle or angle of repose. If theta is less than theta c, the body is not going to move. It is not moving. If theta is c is equal to theta, means it is angle of repose. The body is just about to slide. When theta is greater than theta c, the body will move. Is it clear? Okay, now see this. This is weight of the body always acts. I am making another diagram. See this diagram. Theta. This is an object on the inclined plane. Now the weight of the body will act in downward direction mg. The normal reaction on this surface will be like this. On the surface, this is normal reaction. Clear? Means this is normal. Then this square angle will be also equal to theta. Now the component of mg along this direction. Towards the angle, what is the component? Towards the angle, what is the component? mg cos theta. Perpendicular to mg cos theta. What is the component? mg sin theta. This component is mg sin theta. This component is mg cos theta. And perpendicular to the surface, this will be normal reaction arm. And the friction forces the body will move due to this mg sin theta. It will move in downward direction. Then friction will act in opposite direction. This is F. This is mg sin theta. This is R. This is mg cos theta. And this one is mg. When the body is not moving, use F is equals to ma. Use F is equals to ma. What is F? Total force acting on the body, and A is acceleration. First of all, we will see in this direction. Suppose theta is equal to theta c. The body is not moving anywhere. Clear? Or this is suppose this angle is theta. Then R, this is in this direction. Then opposite direction. In one direction force is positive, then in opposite direction it is negative. Then F is the sum in this direction. First of all, we will take in this direction total force F, then in this direction total force F. Okay? In this direction, R minus mg cos theta is equals to, this is F, the total force acting in this direction. R in one direction positive, then in opposite direction negative. R minus mg cos theta is equals to ma. But there is no acceleration, it is not moving. Since it is not moving, no acceleration, it is 0. This is equation 1. Now, in this direction, mg sin theta, in one direction is positive, in opposite direction friction force minus F. Since it is not moving in this direction, 0. This is equation 2. Now see equation 1 and 2. See equation 1 and 2. mg sin theta is equals to F. mg sin theta is equals to F. And mg cos theta is equals to R. Now again dividing both sides, mg and cancel, tan theta is equals to F by R. What we got from there. Okay? Thank you so much.